In this video, we look at how atoms form covalent bonds by sharing pairs of electrons. Like this single covalent bond between two hydrogen atoms that holds a molecule of hydrogen together. The shared electrons are attracted to both hydrogen nuclei, and the covalent bond is the mutual pull on these shared electrons, like a tug-of-war between the atoms. Covalent bonding occurs between non-metal atoms. The number of bonds each of these atoms can form depends on the number of empty locations in their outer electron shell. Hydrogen has just one empty location, so it forms one covalent bond, as in this molecule of hydrogen. Oxygen has two empty locations, so it forms two covalent bonds, as in this molecule of water. Nitrogen forms three covalent bonds, as seen in this molecule of ammonia. And carbon forms four covalent bonds, as seen in this molecule of methane. And these atoms can bond together to form much larger molecules, like this glucose molecule, which contains 24 atoms. Or this peptide molecule containing 179 atoms. Or this molecule of hemoglobin, which contains almost 10,000 atoms held together by covalent bonds. So let's take a closer look to see how atoms form these covalent bonds. Hydrogen chloride is a gas at room temperature. The hydrogen chloride molecules each have a hydrogen and chlorine atom held together by a covalent bond, the result of a shared pair of electrons between the hydrogen and chlorine electron clouds. Hydrogen, atomic number 1, has a single electron, and it needs one more to complete its shell. Chlorine is in group 17, so it has 7 electrons in its outermost shell. This third shell holds 8 electrons, so chlorine needs one more electron. Both atoms complete their shells by sharing a pair of electrons. The hydrogen atom now has 2 electrons, and chlorine has 8 in its outer shell. This Lewis diagram shows how the outer electrons are involved in the molecule. The shared pair of electrons is drawn as a line to represent a single covalent bond. Chlorine gas exists as diatomic molecules of chlorine. These molecules have 2 chlorine atoms held together by a single covalent bond, the result of a shared pair of electrons between the atoms. The empty electron locations in each atom are filled when they share a pair of electrons. Each chlorine atom now has 8 outer electrons and therefore a full outer shell. And here's the Lewis diagram with a line representing the single covalent bond. Water, a liquid at room temperature, exists as molecules of hydrogen and oxygen. Each water molecule has 2 hydrogen atoms bonded to 1 oxygen atom, with pairs of shared electrons between the electron clouds. Oxygen is in group 16, so it has 6 electrons in its outermost shell, and it's looking for 2 more to complete this shell. By sharing electrons with the hydrogen atoms, all 3 outer shells are completed, forming covalent bonds and a molecule of water. And this Lewis diagram shows how the valence electrons are involved in the molecule. So, in this video we've seen how non-metal atoms form covalent bonds by sharing a pair of electrons. We've seen that molecules are formed as atoms complete the empty locations in their outer electron shells. And we've seen how the bonding can be summarized by a Lewis diagram. In the next video, we'll explore multiple covalent bonds between atoms, like this double bond between oxygen atoms, or this triple bond between nitrogen atoms.